Cosine theta equals x over r and can be written like x equals r cosine of theta. Sine theta equals y over r and can be written like y equals r sine theta. Tangent theta equals y over x and can be written like r squared equals x squared plus y squared.
In polar graphing, there is a second set of coordinates. To form polar coordinates in the plane, you must fix point O, which is called the origin or the pole, to form. Get it. From this point, the initial ray called the polar axis is created, where r equals the directed distance from O to P, and theta equals the directed angle counterclockwise from the polar axis to segment OP. If we were to draw this out, r, which equals the directed distance, would be going upward, and P, which equals the polar axis, would be going right. And in the middle of it, theta, which equals the directed angle there, and P would equal r and theta.
How are they going to find the r, Vanessa?
Because your r is a distance.
Okay, good. Go.
6.
As we know, in a standard graph, we have x and y coordinates. Now, x and y coordinates are known as rectangular coordinates because if you were to plot any point, you would simply be creating a rectangle. Now, for polar coordinates, it's different. Your x is going to be your radius, and your y is going to be your theta. If we were to graph this, this would be your radius. Hope I spelled it right. And then the space between here would be your theta. Now, for polar coordinates, it's very different. You're going to be creating a circle within the 0, 0. So, right? It's a circle. And as we know, in a circle we have 360 degrees. We're going to be using the equations that we previously saw in the basic relations section of the video. We're going to be using tangent theta equals y over x and r squared equals x squared plus y squared. Now the points that we're going to turn into rectangular conversion is going to be 3 and 2. Did you take the picture of earlier of the board? Let me copy it down.
So were you done?
Yeah.
I'm still recording.
Okay, as mentioned before, our coordinates are 2 and 3, x being the 2 and y being the 3. So to solve it is basically really easy. All you're going to do is take these coordinates and plug them into your r squared equals x squared plus y squared equation. So if we write it again, r squared equals x squared, which is your 2. So 2 squared is 4, plus your y squared, which is 3, which 3 squared is 9. And if you add them, r squared will equal 13. Now, to turn it into a polar coordinate, you have to square it. To get rid of this square, you obviously have to square it. So, your new point is going to be square root of 13. That's your x. But now we have to find your theta, which is going to be your y. To find the y, which is your theta, it's a little different. You have to use your tangent formula, which is tangent.
It's already up there, Vanessa.
Oh, yeah, it is. Hold on. Okay, your tangent theta, which equals y over x. So what you're going to do is, to get the theta, you have to do the inverse of tangent, which is theta equals tangent y over x. And the same thing that we did earlier with the substitution, you're going to do the same thing. So you're going to do tangent over 2 over 3. And to find this, you can just simply plug it into your calculator. You want to pause it?
I think that's reversed, dude.
Why?
Because it's y over x, not the other way around. You have it backwards.
How to convert rectangle equations to polar equations. The equation we're going to be using is y squared equals x cubed. We're going to use the sum conversion, which is going to be y equals r sin x r cosine. The first step you have to know is that y is going to be this and x is going to be that and y is going to be this. So you're going to plug it in. Then what we're going to do is we're going to distribute. Then what we have to do is move r's on the left side of the equation and these two on the outside of the equation. So it's going to look like this. Then you use a trigonometric definition.
Trigonometric.
Which is going to give you r equals tan 2 0. Then this is your answer.
We are going to graph 4 sin 3 theta. And so what we're going to do first is we're going to click mode. Make sure degree is highlighted and pull as well. After that, we're going to click window and set it in our theta min is going to be 0. Our theta max is going to be 360. Our theta step is going to be 5. Our x min is going to be -6. X max is going to be 6. X scale is going to stay the same, if that's what that is. Our y min is going to be -4. And our y max is going to be 4. And that stays the same. After that, we're going to go second window, and we're going to set that to 0 and 5. The next step is going to be pushing second, zoom, and making sure polar GC is highlighted, as well as label on. Then this is whenever the graphing comes. We're going to push y equals and plug in our equation, which is this one. It's 4 sine 3 theta, and this it's right here. We're going to close our parentheses and push graph. That is cool, huh? I know it is. After that, we can go to second graph and get our points from here if a question asks you for the polar coordinates. But make sure that when you're going to create the polar coordinates, this side comes first, it's r, then theta.